All of these test tiles have been painted with the clear transparent. The clear transparent will turn to liquid glass when the kiln reaches 1860 degrees, or cone 06. It's really important that you don't get any clear glaze on the bottom. You can see there's a little bit of clear glaze that has come through the hole, and that will need to be wiped off. If it's not wiped off, this will stick to the kiln shelf and it'll have to be broken to take it off of the kiln shelf. There's another way to prevent that problem, and that's to put the tile on stilts. Here's the kiln. Right now we can see that it's at 108 degrees. So the thermocouple, or the thermometer inside the kiln, is telling us that it's 108 degrees right now in the kiln. That's because it was just unloaded and reloaded, so it's still hot. Here are the test tiles that we just painted, and they are going to go on the top shelf of the kiln. The kiln is stacked with multiple shelves so that you can fit a lot of projects into the kiln. The kiln takes a lot of electricity, so we try to get as many projects in it at once as we possibly can to save energy. The kiln takes so much energy that it requires a giant plug. It's pretty big. To get enough energy to heat the kiln up. And this kiln can actually get up to about 3,000 degrees. Your oven at home in your kitchen can get to about 600 degrees. So this kiln gets very, very hot. If we wanted to put another layer on top of the one that we're putting in right now, we would just put some stilts like this. They have to all be the same size, or you can use little ones to make them the same size. And then shelves are stacked. So here's the stacked shelf. If we wanted to use another shelf, this is how we would stack it. We don't need to use another shelf because we have nothing else to put in the kiln. This is a stilt. It's basically a little piece of clay with some metal prongs, and it's a special kind of metal that can get very hot because some metal will actually melt in the kiln if it gets hot enough. And this stilt just helps to raise the test tile up, or the project up, so that it's not going to stick to the surface of the kiln shelf. Here's another one. This is a cupcake project. This is the icing part of the cupcake. And you can see there's a little bit right there. There's a little bit of clear glaze. And so I'm just putting it on a stilt. I'm cheating. But that'll do the same thing. It'll make it so that wherever there's clear glaze, which is the pink stuff, it will not stick to the kiln shelf. These test tiles cannot touch, because remember, they have liquid glass painted on them. If they touch, they'll melt together in the kiln, and then when it cools, they'll be fused together and we'll have to break them to get them apart. Not all glazes are the same. The glazes we just used were underglazes, which are basically like clay, and the pink stuff is the glass that goes over the top. A lot of glazes already have the color and the glass mixed together with something called flux. Flux lowers the temperature where all the materials in the glaze melt so that you don't have to use as much energy to fire them. These are some of the many different kinds of glazes. Let's paint some on some test tiles. Here are two different kinds of glaze that we are going to test on some test tiles. This one is Speedball Low Fire Rojo Red. This is an Amico glaze. It's an opalescent formula, and it's called Aquamarine. The cool thing about both of these glazes is that they both contain the mineral copper, the metal copper. And different things are going to happen with these glazes in the kiln, because they're going to go through a chemical reaction caused by the heat of the kiln. So we're going to paint red Rojo glaze on this, and we're going to paint aquamarine, which is like a blue-green, on the other one.